we're going to talk about like sketching for sine and cosine graphs. If we have time, I want to also go through for the solving, but I'm not sure if I have the time. So for this exercise, I have combined 3 exercises together. Well, I'll directly go to the complex version and we talk about directly from there. So maybe you can add a bracket here. Okay, add a bracket around the n, and that's the value you put in sine, and the plus and minus b is the moving up and down, like the vertical translation. So just make it clear. Okay, just make it clear. So there's another bracket. All right, so with those letters, let's see what those letters are in charge of, like what they will, how they will affect the shape of the graph. So first of all, I will start from the b value, like the constant we add at the back. Okay, so sine x plus 1, like sine 2x minus 2, like this constant here. So this constant is talk about the mean line, or say the middle. Okay, so where is the middle of the graph? So you know sine graph got the maximum and the minimum, so the b value is the middle. Okay, the b value is the middle. Okay, and the next thing we'll look at is the a value. Okay, the next thing we'll look at is the a value. So a value is the amplitude. Okay, a value is the amplitude. But remember, like this a must be a positive number. Like when you talk about amplitude, that must be a positive number. Okay, must be a positive number. So if say a is negative 2 sine something, we say the amplitude is 2. Okay, we say the amplitude is 2. We don't say it's negative 2. So you know that you have middle, and that's the b, y equals to b. That's the b line. And then you have amplitude a is how far it can move up and down. Okay, how far it can move up and down. So say a is 2. I can move up 2 units to reach the maximum line, and then I can go down for 2 units to reach the minimum line. So these two numbers, a and b values, can give you the 3 lines. Okay, so that's the maximum line, minimum line, and the middle line. Okay, so that's what a and b will be done, will do to the graph. And then the last thing we worry about is the n value. Okay, it's the n value. So what is this n? This n is in sine. Okay, this n is in sine, and it's the coefficient of the variable. Okay, it's the coefficient of the variable. So the coefficient of the variable, well, it can be negative as well. For example, sine negative 2x. Okay, the negative is doing reflection here, but we take the positive. That number will affect the period. Okay, that number will affect the period. So your graph is getting wider, or your graph is getting like narrower. So that affecting the period. So what period equals to? The period equals to 2 pi over n. But this n needs to be positive value as well. So I put the absolute sign there, which means like you take the positive of that number. So your period is not going to be negative. For example, a is negative 2. You won't say your period is negative pi. Your period is pi. Okay, your period is pi. So not negative pi. And okay, so that's the period. So for this number here, well, this will be a horizontal movement. You can see like I'm writing horizontal movement here, but you don't need to worry about that number that much. Okay, you don't need to worry about that much. I will show you what I will do. I think my method will be quite different from last year. What you learned, I think most of you learn sketching circular functions by transformation. You think about what sine x looks like, and then how far it moves to the right, and whether there's a reflection. So maybe most of you learn by that method. So I'll introduce another way to sketch it. If you're quite confident about using transformation to do it, just keep your own way. But today I'm going to talk about another method, which see if you think that's better, you can use this one. So this is not going to affect my sketching that much. It's just a horizontal change. Okay, it's a horizontal change. Okay, this is exactly the same if I change sine to cosine. Okay, if I change sine to cosine, that's exactly the same. Everything I talk about here will be exactly the same. The only difference is like sine graph and cosine graph looks a little bit different, like it's transfer pound to units to the left from sine to cosine. But like that's not important. Let's think about the next thing. This is a normal sine graph here. Okay, it's a normal sine graph for one period. I have sketched it for one period. And you can see on my screen I have 4 colors there. Okay, the red one, the green one, the blue one, and the purple one. So why I cut into 4 pieces? Because it's 4 stage. If you think someone, okay, there's a person walking on this path. This is the path. Okay, so someone is on this path. On the red curve, he will reach the top line, and then we'll go down to the middle line, and then we'll keep going down to the like the bottom line, and then go up back to the middle line. So it's with some pattern. The next stage will be maximum and then minimum, mean and then minimum. So it will with some pattern. Also, you can see here, so for one period, this person will experience 4 stage. Okay, moving up, down, further down, and up again. So, and you can see those 4, well, if I cut it here, each stage, the horizontal distance is the same. Okay, it experiences the same horizontal distance. So, my height is changing. But from one height change to another height, the x value is the same. Okay, so what is the x value? Is the period divided by 4. Okay, it's the period divided by 4. So because it's 4 stages, so each stage will experience period divided by 4. So that long for x. Okay, now is the key point here what I'm going to talk about. The key point is if, well, someone just take me somewhere on this path. Let's say I have point A, point B, point C, and point D, and point E. Okay, this path is keep forever. Okay, so moving forever. So if someone throw me at point C, I can't predict what's my next step. I might go up or I might go down, right? I'm at the middle. Well, it depends on which way I go. Like, doesn't matter I go left or go right. Like, it can one up and one down. So I can't predict it. I don't know which way I should go to go up, which way I should go down. But if someone take me to point B, I know I'm at the maximum. Okay, I'm standing on the top. So it doesn't matter which way I go, I will definitely go to the middle, right? Either way, I go to the middle. And then after that, I definitely go down, right? If someone put me at point D, each way I will go up, and then further up, right? That's the pattern. That's the pattern. So the thing is, if I'm at point A, point C, or point E, there's no way for me to predict my movement for the next stage. But if I'm at the B or D point, I know what I'll be. Like, I know where I will go. So this is the key point to sketch the graph. Can I predict what's the next stage? So to find an extreme point, well, I call this an extreme point, so which is a turning point. If you can find the turning point first, I can definitely sketch a full graph. Okay, I can definitely sketch a full graph. Why I can definitely sketch a full graph? If I know, okay, I'm telling you, I have a maximum point here. You know my next step should go down and then further down and go up, like always go this pattern. And also what I will know is this horizontal distance must be period divided by 4. Okay, must be period divided by 4. Because in each period, you need to experience 4 stages. So each horizontal x distance will be period divided by 4. So I can, when I know one point, I can exactly know all the rest of the points. Okay, so it's hard to think here, but I'll show you the one example. They're all working, so that's fine. let's have a look at this example here. Okay, let's have a look at this example here. I'll show you what I'm talking about. It will make much sense. So first of all, I will decide where's the middle, where's the maximum, and where's the minimum. That's always the first thing we do when we sketch it. And I like to sketch it with lines on the graph. So my middle is at 2. And amplitude is 3, so I can go up by 3 units to reach 5. I can go 3 units down to reach -1. Okay, that's the 3 lines. My graph will be on the 3 lines. Okay, so I'll walk on, I'll move up and down on the 3 lines. And the next thing, well, this first step is easy. Everyone can do that. Second step is a little bit tricky, but after that, everything's easy to solve. I want to find the maximum point. I want to find the point that gives me the maximum. In other words, I want to find the t value that can give me a maximum. You know I'll have a lot of maximum on this graph. Any of that will be fine. Okay, any point, any maximum point will be fine, will work. So how to find maximum? That's the key question. How to find the maximum point or minimum point, doesn't matter which one. So, what I'll do, can you see this red box? Okay, the value for that is changing, right? The value for that is changing. Different t will change the value for the red box, okay? 3 times something plus 2. Okay, the question becomes 3 times something plus 2. Can you tell me what's the maximum value this red box can take? What's the maximum value this red thing can take? This one. Like, what's here? What's the maximum value? My t can change. You can change whatever, like infinity, whatever you can change. But what's the maximum you can have? In other words, sine something. What's the maximum value for sine something? Sorry, what's that? No, 2 pi is the angle. Like I put any angle in. What's the maximum thing you can have? 1. 1 is the max. Okay? Can you think about this here? I have the red blue bracket. Can you see the blue bracket? Yeah, the blue bracket I sketch. I can change whatever like inside that. Okay, doesn't matter what I change in the blue thing. The maximum value the red thing can take is 1. Right? Like sine 360 degrees, sine 2 pi over 2, sine 4 pi over 5. Doesn't matter what you put. Maximum is 1. Because sine something 1 like is the maximum, like unit circle, like 1 is the highest point. Okay. Next question is sine what gives you 1? Pound 2. Yeah, good. Sine pound 2 will give you 1. Okay. What's my task? My task is to find the maximum point. That thing, the red thing, maximum is 1. On purpose, I want to make it to 1. Okay? Therefore, the blue things, the blue angle, can you see the blue angle? Must be pound 2. Well, not say must, because there are other values as well can make 1. But the easiest one, like the one we know, is pound 2. So I will make this equals to pound 2. I make the angle become pound 2. Why? Because I want to achieve a max. I want to achieve the maximum value of sine. How I can achieve the maximum value of sine? The blue bracket equals to pound 2. There are other values. For example, pound 2 plus 2 pi. Pound 2 plus 4 pi. But why take that difficult values? I want just the easiest one. I just want 1 point. 1 point is enough, but pound 2 will make the point. So I will solve for it. Okay, when I solve it, I have t equals to pound 2. Okay, it's just pound 2. T equals to pound 2 will make the red box become 1. So my y value will be 5. Yeah, my y value will be 5. Because I know when t equals to that, the bracket becomes pound 2, sine pound 2 becomes 1, and 1 times 3 plus 2 is 5. That's the maximum point. You see, that's the maximum point. Think about another thing. If this 3 is negative 3, then you have the minimum point. Can you think about that? You have the minimum point because minus 3 plus 2 is minus 1. You have the minimum. So when a greater than 0, the amplitude greater than 0, you have max. When a less than 0, you have minimum. Okay, it really depends. Okay, a greater than 0 have max, a less than 0 have minimum. Okay, so now in this case, my 3 is positive. I have the max. Okay, I have the max. So let's label this point. Pi on 2 and 5, max. And what I know is the next stage will move to middle. Okay, it will move. The next special point will be the middle. So to move to the middle, I want to see how long it takes me to move to the middle. Like what's the x distance I need to travel to move to the middle. Then you know like period divided by 4 is the distance. So I need to work out the period. Which is pi. I call that a step size. Okay, each step or step length, like each step what I should take is pi over 4. Is period divided by 4. Okay, it's period divided by 4. So now I'm here. So x, okay, can you see my x value is here now. The next stage will take you pi on 4 to happen. Will be this point. Yeah, that's the distance of pi on 4. So I will have this point. And the next step, I take another pi on 4. Like a step of pi on 4. Then I will have this point here. Okay, max, middle, minimum. Another pi on 4, which I reach here. I will have this point here. If I go back, well, I haven't reached the domain yet. If I go back, reach here, it will be the middle as well because max moves to the middle. And that's the end point. Yeah, and that's the end point. You can see the domain is pi on 4 to 5 pi on 4. So you can connect the graph. Can you see I haven't think about any transformation thing? Like I haven't really considered about any of the transformation. Okay, so I will label the endpoint. And I will label the maximum and minimum. Okay, this is an easy one because the point is very nice. Okay, the point is just good distance and very nice. Yes? Yes, but like not for this question. We'll talk about the labeling because I can't solve out the exact x coordinates here. I need to use calculator. We need to label it. And also the question will emphasize like you need to label x-intercept, but not for this one. This one can't label. Not at a good place. Any questions for this one? Like for this particular question? If not, we'll move to a little bit like a harder one. Okay, we'll move to a harder one. Okay, let's have a look at the cosine graph. Wait, I haven't changed this one. Let me think. Change that to a 1, please. Change this to 1. And change this to pi. Okay, we have a bracket here. Okay, still all the same. So I'll label, this is 1, this is 2, 3, and 4, and that's -1, that's 0. You can see the scale. Okay, also for the x-intercept, for the x, I'm not sure how clear you can see the grid on yours, but for every 2 box, I want that is like for every 2 box is a distance of pi on 12. Okay, for every 2 box, I want the distance of pi on 12. So what I'll label here, I will label number 1, 2, 3, 4, like 1 pi on 12, 2 pi on 12, 3 pi on 12. It is too small to label, so that's 1 pi on 12, 2 pi on 12, 3 pi on 12, 4 pi on 12, 5 pi on 12, 6 pi on 12, 7 pi on 12, 8 pi on 12, 9 pi on 12, 10 pi on 12, 11 pi on 12, and the last one will be exactly 12 pi on 12, 12 pi on 12, which is pi. Not sure how clear you can see it, but like that's how I will give you the scale. It's just so hard for me to label it on the computer. It's too small, so I will just label as 1, 2, 3, 4. So that's a unit of pi on 12. Okay, after we do that, let's label the 3 lines. Okay, you label that by yourself, like the 3 lines, the max, the middle, and the minimum. Where are they? After you finish, you can have a look. So you have 3 lines at those places. Okay, please do another thing. Change the 2 to a -2. Change the 2 to a -2. It won't change anything. It's just change the negative because I want to see the want you to see the minimum. Okay, now I will put a box around the cosine. Okay, same as the sine. Now the next step is to find either maximum or minimum. For cosine, what's the maximum value of cosine can have? 1, right? Cosine something will be 1. Cosine what equals to 1? Cosine what equals to 1? Sorry? The easiest one. Give me the easiest one. 0. Okay, cosine 0 is 1. Yeah, or 2 pi. but like 0 is better. Well, 2 pi will be correct as well if you use 2 pi to calculate, but like I want to take the easiest one. Same as the sine. Then the angle needs to be 0 to make the maximum to happen. So I will make 2 bracket x minus pi on 3 equals to 0. So I can solve out my x equals to pi on 3. Pi on 3. Next, is this a maximum or minimum? Y will equals to what? Y will be what? When x equals to pi on 3, what's the y value? Anyone tell me? What is it? -1. Good. Because the red is 1. 1 times -2 is -2 plus 1, that's -1. So I will have a minimum here. Yes, that's a minimum. Okay, that's a 4 pi on 12. Okay, that's a 4 pi on 12. So where is it? 4 pi on 12 and the minimum, which is here. Okay, which is here. 4 pi on 12 and minimum, which is there. Now I want to see how I can move to the next point. Okay, how I can move to the next point. So I will find the period. Period equals to 2 pi over 2, which is pi. So each step, okay, a step length equals to pi over 4. And that's a 3 pi over 12 because I have a denominator of 12. So that's a 3 pi over 12. Okay, that's what each step you travel, like how much you x travel for each point moving. So 3 pi over 12, so that's 3 blocks. Okay, that's 3 blocks. So I'm originally here. Move 3 blocks, I'll move to 7. Move 3 more, I'll move to 10. And I want to move another 3 more, but I don't have 3 more. So let's say pretend the 13 is here. Okay, move 3 more. And then move backwards. Want to move 3, I will have the 1 here. But I haven't reached 0 yet. I need to keep moving 3 units, okay, to that side. So let's pretend the -2 is here. Or somewhere outside there. Okay, that's the x traveling. Like for each point, what is your x location? Now, see, okay, at the 4, I have minimum. So at the 7, I will have min line. At the 10, I will have the maximum. And at the 13, I will have min again. Right? Now go backwards. I will have the min at the 1. And I will have the max at the -2. Okay, that will be -2. But you know I'm not going to sketch for that point. Like it's not important. Like it's outside the domain already. But I want you to see the pattern. So the pattern will be I don't know the exact point yet. Well, you can see there will be endpoint. It should be further that way, but I don't have space to draw it. So I will have some endpoint here. And also this side, well, 12 is here. So I will have endpoint here as well. Okay, I'll have endpoint here as well. I don't know where is it yet. Okay, I don't know where is it yet. I need to calculate that, but I know I'll stop somewhere. Or I haven't calculated out the x-intercept yet, so it's a rough shape. Okay, but that's the shape. I know all the what is called turning point. That will be 10 pi on 12, which is 5 pi on 6, comma 3. That's the turning point. And also this one is pi on 3, comma -1. That's the minimum we find. I can see the shape. Okay, I can see the shape already. Now the next thing is to find the turning point, endpoint. Okay, to find the endpoint. So we can evaluate when x equals to 0, y equals to -2 cosine -2 pi over 3 plus 1. Okay, we start the 0 in, that's a -2 pi over 3. So we know -2 pi over 3 will be here. Also, this is the tangent quadrant called a reference angle pi over 3. So y equals to -2 negative cosine pi over 3. Change to reference angle, but it's negative. It's the tangent quadrant. Well, cosine pi on 3 is a half. So that's a +1 plus 1. Y gives you 2. Y gives you 2. So this point here is 0,2. And we say when x equals to pi, y equals to 2 cosine 2 pi minus 3, that, and then plus 1 -2. So y equals to -2 cosine. Okay, I'm not subtracting that. Instead, I will expand it. Okay, why I'm expanding that? Because I have a 2 pi there. So that is just equals to -2 cosine -2 pi over 3 plus 1. Well, you know the 2 pi. I don't really need the 2 pi. So that's exactly the same as above. Can see the top line there? So y will still be 2. So it's pi comma 2 again. So this point here is pi comma 2. Okay, that's how you calculate endpoint. Just substitute. Okay, you substitute, you find the endpoint. Because the endpoint is not on this 3 line. So that's why we need to work that out. If it's just on the 3 line, like the sign question we sketched, that will be easy. Okay, that will be easy. Okay, so that's the shape of the graph. Okay, think about the way I have sketched it. Like this method is quite different from like what's the normal way you teach like the circular function sketching it. So have a think about this method. Do you really like it? If you like it, you can follow that. This will reduce a lot of error, because think about the transformation. If you have some negative and also plus translations, it will be very hard to think about. Okay, so reflect first and then translate, or translate first and then reflect. It's very hard to think about. So by using this method, you don't need to think about any transformation. Just a normal sketching. Okay, find the starting point. Find the step length, which is period divided by 4, and then we just keep plotting points. We just count. Okay, 1, 2, 3, dot, 1, 2, 3, another dot. We just keep counting. Any questions you want to ask? No? Okay, if you don't have any questions, I think I will stop here first, and you can think about this question. Okay, think about those two questions and try some of the exercise on the textbook. Okay, and try some of the exercise on the textbook. See whether this one works for you or not. If not, you can go back to your normal way to sketch it.